create these things yourself, right, when you do your project. So it depends on how the code is written, right? So when this happens, you have to go back and say, okay, in my product or whatever I'm dealing with, let me go and check what is the mechanism they have defined.
It's how you write it.
Yeah.
It's how it's going to work.
Exactly, right? But good eye, like that. Okay, so that is where we are with that figure, right? So the three scenarios, remember, the three scenarios that are described here, and I want you to make sure that you understand that. One is a proper transmission, no problem. Another one where the frame gets lost. Another one where the acknowledgement gets lost, and the frame has to be discarded because it's a duplicate frame. Okay, so please make sure that you understand that as opposed to the other one, and remind me to work out problems at the end or indicate questions so that you know to what extent you have to understand this, right, for preparation for the exam. Okay, assume that in a stop and wait ARQ system, the bandwidth of the line is 1 Mbps. 1 bit takes 20 milliseconds to make a round trip, and you have to calculate the bandwidth delay product. So that's a new concept that comes in, bandwidth delay. Okay, and it was touched upon earlier in which chapter? Chapter 3. Okay, we talked about bandwidth delay, so it actually has to be calculated here. So if the data system data frames are 1000 bits in length, we have to find out the utilization percentage. So now we're looking at the efficiency. So suppose you have stop and wait ARQ, and this is the situation, how much utilization is occurring. Then we'll look at another one which is a little more sophisticated and try to increase the utilization. So what is happening is that 1 bit takes 20 milliseconds, okay, and the bandwidth is 1 Mbps. So are we really